All right, so we're going to work, this is complex fractions. When we work with complex fractions, that means that we have fractions within fractions. All right, so we still have a numerator and denominator. So this is our numerator, and this is going to be our denominator. Now, as you can see, within our numerator, we're adding two fractions, and in our denominator, there's another fraction. First thing that you should do is just separate this stuff. I want to look at the numerator separately from the denominator, which means I'm not going to use the fraction symbol anymore to break these up. I'm going to use the old school division symbol. So 4 over x squared divided by x plus 5 all over, whoopsies. What am I doing here? Oh my goodness gracious, that's not right. It should be 4 over x squared plus x plus 5 over 2. And there's your old school division symbol. There's my numerator, and there is my denominator. So we're going to break it up like that so I can see what's going on. I can start to think about what I need to do. The reason we want to do that is because we're dividing fractions. That means we're going to do that KCF. We're going to keep, change, flip. But before we can do keep, change, flip, because dividing fractions is not easy, multiplying is a lot easier. Before we can do the KCF, we need to have a single fraction on my numerator. Right now, I have one fraction being added to another fraction. So we're going to have to work with that first. Right? So we're going to have our 4 over x squared plus x plus 5 over 2 being divided by x plus 5 over 2. So over here, I want to get that common multiple for my denominator, which is 2x squared. Right? So that means I got to multiply by 2. And on this side, I need to multiply by x squared. Which means my whole top of the fraction, x plus 5, needs to get multiplied by that value. Right? So right now I get 8 over my 2x squared plus x squared plus my x plus 5 all over 2x squared. And remember, we're still dividing yet. We cannot KCF it. Can't go keep, change, flip because I need to have a single fraction. So I'll go ahead and do some distributing. This becomes 8 plus x cubed plus 5x squared all over 2x squared being divided by my denominator. So now I have a single fraction on my numerator and I have a single fraction on my denominator. So now we're at that point where we have two fractions being divided. Now from here, this is our KCF. Keep the first fraction, change the operation, flip the second fraction. Right? So we're going to write this as 8 plus x cubed plus 5x squared being divided by 2x squared. Change it and flip it. So now we can actually work with this. Now we actually have a numerator that we can multiply with another numerator, denominator multiplied to another denominator. All right? So when we have complex fractions, really what we're trying to do is that KCF. You got to be able to recognize, do I have two fractions being added? Okay, I'm going to have to combine them. How do I combine them? How do I add fractions? I need that common multiple on my denominator. Right? So now I'm going to go ahead and rewrite this. Multiply your numerators. Multiply your denominators. The last thing that you could actually do if you wanted to, you can go ahead and distribute through 16 plus 2x cubed plus 5x squared. Don't multiply out the denominator, just leave it. Keep it as 2x squared and then parentheses x plus 5. If you want to reorder, you can reorder the numerator. But there you go. So, complex fractions. You have fractions within fractions. Separated, old school division symbol. If you have fractions being added, bring them together. Then you can do your KCF, keep, change, flip, and then it's a lot easier to work with. All right, so that would be our final answer.